Ladies and gentlemen, this is a topic request from our ambitious student who is in Algebra 2 Goal 5. There's going to be a separate video coming up for Algebra 2 Goal 5 later on dealing with, where's my mouse, Family 3, but first things first, the specific topic request is synthetic division. So, synthetic division is one of those topics when I was doing the software over the summer a couple of years ago, it was a topic where I just kept having to go back to the explanation, go back to the trained math teacher, just kept going back. And then once it finally clicked, it was like, oh, and this is low-key kind of one of my favorite topics to teach as a result, because I can still remember that aha moment, which teachers don't have nearly with as much frequency as students. What's happening is this is a shortcut to polynomial long division. That's why when we're looking at our topic lists, it's listed as the last one. It's not the most versatile tool in your kit, because you can only make it work if you have one x and one number, and that way you can write it in a particular format. That's sort of the catch-22 with this topic, but once you understand how the shortcut works, it makes the work low-key kind of easy. So let's zoom in a little bit, click. All right, using synthetic division, Using synthetic division, find the quotient and the remainder when blah 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 is divided by blah blah blah. Okay, and they give you the setup of the format. What you want to kind of zoom in on is look at what your coefficients are. You have a 2, a -8, a -14, a 19, and a 5. All of those numbers are now copied and pasted here in this line. So these are our coefficients. 2, 2, -8, -8, -14, -14, and so on. So that's where all of the numbers are coming from. Now, what happens is there's a little bit of a pattern here. So to begin, the 2 drops down because because the 2 is the odd one out. We can't do anything with it since it's the lead coefficient. The lead coefficient has some like special properties, yada yada yada. But here's the pattern. Step 1, we're going to multiply. So what is 5 times 2? 10. And then you can see here with the line and everything, we have it tailor-made for addition. So what's -8 plus 10? 2. Funny that. Multiply again. What's 5 times 2? 10. And now we're starting to see what the pattern is. Let me redraw it up here. So what's happening is whatever number down here is multiplied by your 5. The 5, by the way, comes here. Most important thing is that you want to flip your sign. For this topic, for synthetic division, they do all of the sign flipping, etc., and all of the formatting that you need. But eventually, there are a couple of later topics where you kind of want to set up your synthetic division on your own. So always be aware of what the format looks like, just so that you can be comfortable with eventually doing it on your own. So anyway, you have all of your all of your coefficients here. Computer, brush tool, coefficients here, whatever. You have all of your coefficients here. You have your line. Whatever is coming down in this line is going to serve two things. One, you're going to be multiplying by 5. And then the second thing you're going to happen is that these become your new coefficients. I'll explain that in a second. But then what happens is you're always pushing down, pushing down, pushing down, pushing down. So here, -14 pushes down into the 10, and I am left with -4. Multiply times 5, that's -20. 19 minus 20 is -1. 5 times -1 is -5, and 0. That's all you're doing. The pattern is very soothing and very repetitive. You're always pushing down, and then you're always multiplying. That's what's going to be happening, excuse me, my goodness, every single time. So let me rewrite that so that it looks a little bit neater, because the boxes here and the screen grabs don't look particularly attractive. All right, so what did we have? We had 2, -8, -14, 19, and 5. We dropped the 2 down. 5 times 2 is 10, push down. 5 times 2 is 10, push down. 5 times 4 is 20, push down. 5 times -1 is -5, push down. All of these numbers here are going to end up going here. So This very last one we're going to box off for a second because this is going to be your remainder. That's what goes specifically. I did not give myself enough space when I did these screen grabs. Your remainder, your 0, is what goes in this box. So the 0 is going to go here. The next thing is that all of these, like I said up here, are going to be our new coefficients. Now this can be tricky for some students, and it was tricky for me. Most of the mistakes when I was doing this topic and kept having to go back to the explanation was because I didn't completely understand how the coefficients were happening. What I ended up doing, and I want to see if this helps you, let me know in the next email, is I am looking here, if you look at ignore the coefficients now and look at your variables. You have x to the 4th, x to the 3rd, x squared, x, and then number. This is what's called descending order because your exponents are constantly getting a little bit smaller every time. That descending order gets copy and pasted here. So you see how my last number here doesn't have a variable? This number here doesn't have a variable. My next number has an x, therefore this has an x. Next is x squared, and then this will be x cubed. And this here then is what gets crammed into this tiny box. Obviously in the software they give you all the space that you need. So 2x squared plus, 2x cubed. 2x cubed plus 2x squared minus 4x minus 1 squiggles right into there. 0 is your remainder, and that's how the synthetic division is done. What it is ultimately is a shortcut for polynomial long division. If I have it in this very specific format, I can set myself up and then get all of my answers with a lot less pain, I guess, with long division. This is where me being a math teacher is a problem because I never had a problem with long division, but students always tell me, oh, mess. So I want to talk about this one. I'm smarter this time, and I'm going to set it up in advance. So we have the 2, we have the -1, we have a 0. I want to talk about that 0, but let me finish setting up. And then -14, and then we make our line, and then the -1 drops down, and we're all set. All right, where did the 0 come from? Well, I didn't have, my screen grab went hooey, but I found another one that had the same problem. You see how we have this little 0 here? What does it mean? It's like question marks popping out of the universe. Well, if we're looking at what we were talking before about the exponents, there's your constant, there's your x squared, question mark, and then there's my x cubed. Well, if I look at the original problem, is there an x squared here? No, there isn't. So when you see a 0 in these, what that is a placeholder for something that's missing. Since eventually you're going to have topics where you're setting this up on your own, that tends to be a tricky point, and I want to point it out early so that I can at least say I've told you this, and then we'll talk about it more in a later topic. So back to formula. -1 pushes down, 2 times -1 is -2. Pushes down, 0 minus 2 is -2. Now we multiply, 2 times -2 is -4. Push down, 11 minus 4 is 7. 2 times 7 is 14. Push down, 0. So our remainder here, box it off, that's our remainder, so that's what goes here, 0. And then you have the number x, you have 2x, and then you have -1x squared. Excuse me. Couple more examples because I want to make sure you're comfortable with this first. So we're going to set ourselves up. We have 2, -1, 0, because there's no x squared here, 4, and 6. So -1 pushes down, 2 times -1 is -2, pushes down is -2, 2 times -2 is -4, pushes down is 0, ha 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 ha, 2 times 0 is 0, and here's one, our remainder now is 6, so that's what's going to go in this little box here. And remember, your answers go in the much bigger box when the software gives you space. So in this one, there is no constant. Your constant is 0, but you do have a -2x and you do have a -1x squared. You can be ardently adherent to format and put in that +0, or if you're a little lazy like Ms. Dubois, you just put in -1x squared minus 2x. Either of those is fine, and then cram it into your answer box. Once more, I want to make sure we're absolutely comfortable with this. No zeros to be had here because every single exponent is covered. So let's see here, -4, so we're going to flip the sign. And what are our numbers? We have -3, 9, 11, and 8. You'll notice I'm actually not even looking at this. I'm pulling my numbers right from here because I want to get into the habit of that really early. So negative 3 pushes down. 4 times negative 3 is negative 12. Push down. 9 minus 12 is negative 3. 4 times negative 3 is negative 12. Push down. 11 minus 12 is negative 1. 4 times negative 1 is negative 4. 8 minus 4 is 4. That last one is our remainder, so that's what goes in here. And then what do we have? We have minus 1 as our constant, 3x, and then 3x squared. And then that number is what goes in there. So I've been through 4 examples now. You can kind of see how rhythmic the actual numbers start to fill in after a while. The tricky part for most students when they're getting used to it is inputting the variables and their exponents. So be very careful with those. If you'll notice, instead of going from left to right, I tend to do it from right to left just because as someone who struggled with this topic, I did not get it until I literally switched my orientation and started going from right to left. If that helps, hopefully this will be everything you need to get through this topic. The next video, since you talked about the fact that all of your topics that you're getting stuck on is for factoring, those are actually mostly easy topics. This one in particular you're going to laugh at when you realize how easy it is. I will make a video for that hopefully tomorrow. I'm trying to churn out 3 videos a day. This will make it 4 videos, and it's just fundamentally a question of how much time I have, but it should be up either today or tomorrow, and see you in the next one. Stay happy, stay healthy, stay safe.